Hello, dear followers. This is Arian Himmel, your hostess for mostess. It is just before I start. It is hot as hell, humid, and I freaking hate this day so far because of the temperature, of course. Like, a little cold would be nice. Right behind me is a dehumidifier running up, but I hope it doesn't bother you. So, without further ado, today is going to be a very different subject, I will say. I usually did some live talks, I did a lot of game streamings and videos and such, but I thought I would move to a different subject. I heard a lot of people that are complaining about a very certain subjects that they have an issue teaching their kids. Parents and kids alike have an issue learning it. So this video is going to be for you, watcher, who are having a very hard time with Common Core math. This here, and yes, I'm gonna be using a board. So let's start this. So Common Core math is usually like really common core, common sense. That's how I would translate it. And let's say that you have 3 times 5 oranges. That will give 15 oranges, right? But a lot of people will write the 5 like 5 times 3 if we say 3 times 5. So over here I will do 3x 5 equals 5, 5, 5. One bag of 5, second bag, third bag. This is a depiction of 3 times 5, and no, it doesn't equal to 555. So you know, it's like if I was to depict it in another way. I have 3 crates containing 5 fruits. 3, 4, 5. 1, 2, 3, 4, 5. Here's a better representation of what would Common Core math look like. It is simple, and yet a lot of people have a hard time figuring this one out. Also, there are things like what is worth more between 1 inches and 2.54 centimeters. Now, what is worth more? None, because both are equal. Why? Conversion. If we were to do 2 inches, what goes in the middle, and 2.54 cm. If we do this, obviously 2 inches overpowers 2.54 centimeters because 1 inch equals 2.54 cm. So basically, if you have 2 inches and you have 5.08 inches, I'm sorry, but they're both going to be equal by the rules of mathematics. Do it yourself. I promise you it is the case. Now, if we were to say what's worth more between an hour and 3,601 seconds, which one is worth more? The 3,601, because basically it's going to be in seconds. So I can actually show you 1h for hour equals 3600 seconds, and also 1h equals 60 minutes. Now, something that's highly interesting in this little concept here is that if I was to say, hey, what's worth more, 3,600 seconds or 60 minutes? If you tell me that the 3,600 is worth more, I am sorry, but this is totally wrong. I will have the pleasure of showing you why. To go from in 1 minute there is 60 seconds. So 1 min equals 60 sec. There. If 1 minute equals 60 seconds, then obviously 1 hour will really equal to 3,600, because 60 minutes. So now, what are we going to do? An exponent. Or, you all know, I don't know if you all know, but I hope you know, 6 exponent 2 means that you square up the number 6, meaning that if you were to do a square and a surface, 6 times 6 would actually make 36. Now, to explain to you what I just said, I'm going to show it to you again. Just organizing my paper. So, alright. Now, exponent, and this is where some people also, well, I hope it is in the common core maths, because to me it's just common sense math. So, the squares. Exponents. Now, x covers the surface area. Equal surface area. Now, say that we have 6 to the square. 6 to the square is like saying 6 exponent 2. So it would be like saying 6 times 6 equals 6 squared. So you all see what I did. This is right here. Now, both of these will equal up to 36. But so if the upper square right here was actually 6 times 6, we also could do 6 squared, which is represented by a 2, like this one. So, why do I say this? Because let's come back to our hours, minutes, and seconds. Which one if you want to know how to actually do how really you could square up 60 minutes and actually get 3,600 seconds, is because say that we actually divide everything by 10. So let's do this. We're going to take 3600 divided by 60. Why does it matter? Because let's do it. 3600 there. Now to show you now to continue this, 3,600 is what we're going to divide here, but we're going to divide it by our famous 60 right here. So how many times 60 enters in 360? Why 360? 3, you cannot fit 60 in a single 3. Now you cannot fit 60 in the regular 36. However, because it is a 2 number, you have to get a third number in there, which is the 0. Now this 0 right here will actually allow us, except this kind of splice it right over here. So what do we have? 360 on one side and 0 on the other side. Now, how many times does it enter? 6. After this, we can do minus 360, which equals 0. Then you shoot down the 0 that we spliced on, which is this. So how many times 60 fits in 0? 0. So basically, you got your answer right here. And even more funny, let's totally divide 360 by 10. And let's divide 60 by 10. 360 divided by 10. 60 divided by 10 equal 336 on 6. And right there, you got your square root. You got your base square root on how to do 60 squared to equal 3,600. Take a good glance at it, because this right here is one of the keys. Now to do a little chart, if you want to go big or go home, then I don't know if all of you studied the back of their agendas when you were at school, or if you're at school, study it, because there is an important grill in the back where it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 20, and that goes horizontal and vertical. Well, the X's and the Y's, but that's another thing. But in there is something important where it says 1, 1, 2, 2, 2, 2, 2, 2. If you go from their diagonal and you go down, well, like this more so, you're going to have like 1x1 equal 1, but 2x2 equal 4, and 3x3 equals 9. Those are not just there to look beautiful, they're also to tell you they are exponents. And yes, they are. Like, they're the squares, because if you do a tracing, I'll go and draw it for you. may not be the most perfect square, but you will all understand. I'm gonna do it up to 5. Okay, that's gonna be 16. 12. 1, 2, 3, 4, 1, 2, 3, 4. Alright. Now, over here, we have our glorious square, or a great square here. But why did I make a square? It's all so tacky. Shouldn't there be something more complex? No, there isn't something any more complex to actually explain this to you, subscriber and watcher. Besides, oh, by the way, if you like this video, do subscribe, please. I'll be more than happy, because it will encourage me to make more videos. Now, to explain even better the point that I'm going to make, I'm going to take a few extra pencils, because you can never be safe. Exponents, oh exponents, how much we love you. Thank you for making our lives easier at some point. No, but you gotta thank the PEMDAS for this one. And I'm going to get to this some point later on. Come on, I just want for colors that are not ruined. Forgot to fetch some more. And I hope this works still. This is broken. I didn't open this for a very, very long time. I'm sorry, I'm so sorry. What's this? Oh, it's a white. It's a white pencil. This is not white. Trash. I'm gonna do it with lead. Alright, so now to better explain this in colors, because often we love to rely on colors. Our number 1 here shall be this rotten yellow. It got infected with lead. Now, the second one, the tubes, will be done with lead. Here. Simple enough, right? This is the only thing that you do not need to worry if you use Common Core Math, because they use the squares. Right there, 2 times 2 equals 4, which basically includes the first square on top. Those right there make 4. Now, if we go to 9, if we go to the 3's, I hope this pencil's good. Over here, 3, 3's, threes, boom. And there Why? Because 3 times 3 equals 9. And yet again, you do not need Common Core Math to do this. You only need it if you have to count or do fruit manufacturing or packing or that kind of stuff. Then you'll need to know what does 5 bags of 10 means. It means that you gotta make 5 bags containing 10 of whatever it is. Can be fruit, can be veggies, can be USB keys, as long as it's 5 bags containing what you need to put. Simple enough. And yet there are parents that have an issue teaching this to their kids or explaining it, or kids have a hard time learning it at school. Fortunately, here in Canada, it's already been applied for years, as far as I know. If not, well, apply it as the one thing called common sense maths. But now, let's get back to our good old grill here. So, what goes with all those 5 beige that I used? Simple. All of the other squares that I didn't mark. Now, the bigger one, then the last and not the least, the 4s, 4 exponent 2, or 4 squared, more so, equals 16, which means that it is literally the rest of this square. It's all a square. It's the goal of exponents. When you do it on a single number, you square it. Why do they say that 6 times 6 when you count the square in elementary or pre-K or whatever is the year that you start learning about surfaces and those? They say that the square is always the same number at all 4 corners. If you take its perimeter, then if you take 6s and you take its perimeter, it will have a perimeter of 24, right? So if we take a square, P equal, we'll do 6, 6, 6, and 6 for a square. P equal to 4. And why? Because it's 4 times 6. But A for area, or more so S, equals 36. Why? 6x6. You only need to do it once. If you do it another time, you will get 72. And you don't want that unless you do 36 times 36, which will equal over 900. I don't think that is what you want, right? No? Good. I'm glad we agree. This is what I was saying about exponents. This is if you count the area, the perimeter, there is no way you can circumvent this. However, for the Common Core Math. However, if you actually do a rectangle, it's going to be the same thing, but not to count the surface. To actually do the perimeter, 2 times what plus 2 times what plus 2 plus 2 plus what, 2 plus what, and there you go. But if you do the surface, it's only going to be base times height. Then base times height means that it will be 6 times 18. So 6 times 18, so you do it. Now, if you kept your own agendas, I do invite you to go and use them to and use what I just showed you in this video to teach your kids or to use it for yourself. If you want some more of this, I will be glad to make it, but I will explain the Cartesian plans and a little bit of algebra also, because we all need algebra in life, don't we? Well, somewhat. Somewhat we do, somewhat we don't. Some we can ditch, some we can actually keep. But I will get to you in another video for this one. So this is Ariel Hamel, your hostess from Hostess, signing off. See ya!